Hi, this is Ram Prasad. In today's class, I will be discussing about design of surface drainage system. The design of surface drainage system may be divided into two phases: hydrologic analysis and hydraulic analysis. The main objective of hydrologic analysis is to estimate the maximum quantity of water which is expected to reach the element of the drainage system which is under consideration. When it precipitates, a portion of precipitation during the rainfall infiltrates into the ground as groundwater and a small portion gets evaporated. The remaining portion of water which flows over the surface is termed as surface runoff. Various factors affects the rate of runoff, that is, the rainfall, type of soil, moisture condition, topography, and the ground cover like vegetation, etc. will affect the quantity of runoff. The details of rainfall in the area, including intensity, duration, frequency of occurrence, are also going to affect the quantity of runoff. In the hydrologic analysis, it is all about estimating the total quantity of water which is expected to flow in the drain. Hydraulic analysis is deciding the elements of the drains. Right? So what should be the bottom width of a drain, what should be the top width, what should be the side slopes, and what should be the longitudinal slope of a drain. It is nothing but fixing the cross-sectional dimensions of the drain. Hydrologic analysis is usually done by using the rational formula, that is Q is equal to C into I into AD, where Q is the runoff in meter cube per second, C is the runoff coefficient which is expressed as a ratio of runoff to the rate of rainfall, I is the rainfall intensity in millimeters per hour, and AD is the drainage area in 1000 square meters. Runoff coefficient. The runoff coefficient is not same for all the surfaces. For different surfaces which is having different runoff coefficient. For bituminous and concrete surfaces, the runoff coefficient is to be taken as 0.9. For gravel and waterborne macadam roads, right, so it is 0.35 to 0.7. For impervious soil, it is in between 0.45 to 0.6. For soil covered with turf, it varies from 0.30 to 0.55. For pervious type of soil, it varies from 0.05 to 0.30. When the drainage area AD consists of several type of surfaces which is having different runoff coefficients, then the weighted average value is to be taken in the calculation of runoff. The weighted average is taken by using the formula C is equal to A1C1 plus A2C2 plus A3C3 divided by A1 plus A2 plus A3, where C1, C2, C3 are the runoff coefficients of the corresponding surfaces and A1, A2, A3 are the respective areas. Once we know the value of C, next is to find the value of I, which is nothing but the rainfall intensity. Before going to the rainfall intensity, it is important to know what is time of concentration. Here, the time of concentration, it is the sum of the inlet time and time of flow through the drain. Let us see what is inlet time and what is time of flow through the drain. Here, inlet time is the time taken by the water particle to reach from the farthest point to the inlet of the drain. This inlet timing can be found by referring this chart. In this chart, on x-axis it is time in minutes, on y-axis it is the distance in meters, and different lines are given for different type of surfaces and for different slopes. For pavement with different slopes, we need to refer these lines. For bare soil with different slopes, we need to refer these lines. For thin turf of different slopes, we need to refer these lines. For average turf with different slopes, we need to refer these lines. And on y-axis, it is the distance. As I told, distance is the farthest point from where the water is expected to flow towards the inlet of the drain. For example, right, so the farthest point for the area under consideration is 200 meters in an average turf of 0.5% slope. 200 meters is the farthest point, we need to refer this line, and for average turf of 0.5% slope, we need to refer this line, right? So where this line touches this line, right? So this is almost 41 minutes, right? So 41 minutes is the inlet time for this case. T2 is the time of flow through the drain. T2 is given by L divided by V. L is the length of a drain, which is nothing but the distance between the inlet of a drain and the cross drainage structure, where V is the allowable velocity in the side drain. Once we know the time T1 and T2, we can easily calculate what is capital T. That is nothing but duration or time of concentration. Once we know the value of duration or time of concentration, and once we know the frequency of occurrence of rainfall, we will easily come to know what is the intensity of rainfall. Say for example, if 10 year is the frequency of occurrence of rainfall for 60 minutes duration of time, 60 minutes and for 10 years, right, so it is almost 60 millimeter per hour is the intensity of rainfall, right? So once we know the value of duration and once we know the frequency of occurrence of rainfall, we can easily come to know what is the intensity of rainfall. Next is area of drainage. Usually the area of drainage is calculated by using the contour maps. By referring to the contour maps, we will easily find what is the area which is contributing the flow towards the drain. Usually it is expressed in 1000 square meters. 1 unit of area of drainage is equal to 1000 square meters. Here we came to know the value of C, value of I and value of AD. Once you multiply C into I into AD, right, so we will come to know the value of Q, that is the runoff. The second part is hydraulic design. In this hydraulic design, we are using the basic equation Q is equal to A into V. That is runoff is equal to cross-sectional area into velocity of flow. Here the allowable velocity of flow is not same for all type of soils. For different type of soil, we have different values of allowable velocities. For sand and silt, the allowable velocity should be in between 0.3 to 0.5. For loamy soil, it is in between 0.6 to 0.9. For clay, it is in between 0.9 to 1.5. For gravel, it is in between 1.2 to 1.5. For good type of soil, which is covered with the grass, it is in between 1.5 to 1.8 meter per second. Next step is determination of slope. Usually, determination of slope is done by using Manning's formula. Manning's formula is given by V is equal to 1 divided by N into R to the power of 2 by 3 into S to the power of 1 by 2, where V is the average velocity, N is the Manning's roughness coefficient, R is the hydraulic radius. Hydraulic radius is nothing but the ratio of cross-sectional area of flow divided by wetted perimeter. S is the longitudinal slope. Manning's roughness coefficient is also different for different type of surfaces. For ordinary earth, the Manning's roughness coefficient is 0.02. Earth with heavy vegetation, it is in between 0.05 to 0.1. For finished concrete surface, Manning's roughness coefficient can be taken as 0.013. For rough rubble riprap, we can take the Manning's roughness coefficient as 0.04. And this is about the data required for the design. Once we know the length of road, the width of road and area of drainage, once we have the runoff coefficients for different type of surfaces and the corresponding areas, distance from the farthest point, right? So this is for referring chart 1, type of soil of side drains, this is to fix the value of allowable velocity as well as the Manning's roughness coefficient and rainfall data. Once we have this set of data, we can easily design the side drains. Thank you.